Hello viewers, welcome to our new video. Today we will be discussing a bit of a tough math from factor theorem, exercise 1C from the pure math book of Peng. First, to give you the idea, before doing this math, I want to give you an idea about factor theorem. Factor theorem is basically the same thing as the remainder theorem. The only thing is, in remainder theorem we get a remainder, but in factor theorem we do not get a remainder. That is what it is. Let's say, for example, x squared minus 3x plus 2. Let's say if you want to divide it with x minus 1 and you want to find the remainder. So we set fx equals to this whole thing, x squared minus 3x plus 2, and then since this is x minus 1, we will put x minus 1 equals to 0, which is x equal to 1. So if you put f of 1, then instead of all the x's we will put 1. So 1 squared minus 3 into 1 plus 2. This becomes 1 minus 3 plus 2. You get 3 minus 3 equals to 0. Which basically means there are no remainders. So of course x minus 1 is a factor of x squared minus 3x plus 2. Same thing, let's say 6 divided by 3, you get 2. You do not get any remainder, so 3 is a factor of 6. Same logic. So now here, using this factor theorem, using this logic, this theory, we will try to solve this. What does it say? It says, given that x squared minus x minus 2 and x cubed plus kx squared minus 10x plus 6, this big number, big expression, have a common factor. Find the possible values of k. That means these two expressions have got a common factor. Okay. Now let's start from this. X squared minus x minus 2. Can we factorize these? If you can factorize this, then using those two factors, we can try to figure out the value of k. So I'm trying to do a middle term here. So x squared minus, this is minus, so this is twice x plus x, and this is also minus, so minus and plus and minus. Ultimately I am all right here. So if I take x as common, x minus 2. If I take plus 1 as common, I will get x minus 2. Then if I take x minus 2 as common, I will end up with x plus 1. So now I have factorized this particular expression into x minus 2 and x plus 1. So here we get two values of x. Either x equals to 2 or x equals to minus 1. These two values we will be putting here to find the possible values of k, because these two, either one can be a common factor of this one with this expression. It says they have a common factor, but I don't know, or we don't know, which one is the common factor. So we will have to try with both. So putting x equals to 2, we get here in, let's say I can write it here. I can write it at the whole expression. That will be easier for you to understand. We get, if you put 2 here instead of all the x's, plus k2 squared minus 10 into 2 plus 6. And we get that's equal to 0, because we'll have to find the factor, we'll have to find the value of k. It is also a factor, so this is 8 plus 4k minus 20 plus 6 equals to 0. and then if we do, this is 4k minus 6 equals to 0, or k equals to 6 by 4, which is k equals to 3 by 2, or we can write 1.5. So in this way we can get one value of k, which is 1.5 if we put x equal to 2, or if we consider x minus 2 as a factor of this whole expression. And since we are considering this as a factor of this expression, we are putting it equal to 0. So now here we have got this value of k, putting x equal to 2 or x minus 2 as a factor of this big expression. Now let me do the other part, putting x equal to minus 1. So x equal to minus 1, we get minus 1 cubed plus k into minus 1 squared minus 10 into minus 1 plus 6 equals to 0. Again I have to put it equals to 0 because I am considering this as a factor of this expression. This is how we are using the theory of factor theorem here to solve the math. So ultimately we get, if you solve it, minus 1 plus k plus 16 equals to 0, or k equals to minus 15. So you get one value of k as minus 15 and another value of k as 1.5. This is your math, and using factor theorem we can solve this. Thank you very much.